Hello students, today I am going to discuss thermodynamics important terms, right? So thermodynamics means, thermo means heat, dynamics means flow. Thermodynamics means the study of the flow of heat. Thermodynamics is the study of flow of heat. So to understand the thermodynamics, we need to understand some terms. To understand the thermodynamics, you need to understand some terms. Those are system, boundary, surroundings and universe. First four: system, boundary, surroundings and universe. What is system? What is system? So any specified path that is under study. So suppose I want to study about this pen, then this pen is called the system. I want to study a glass of water in a glass. I want to study the water in a glass. The water is the system, right? Any specified part that we need to study, that is called system, right? So the system boundary. What is the boundary? The boundary that differentiate the system and surroundings. What is the system? The specified part that we need to study is the system. Other than the system, the remaining all are surroundings. Other than the system, the remaining all are surroundings. The line which separates the system and the surroundings is called boundary, right? If you take glass of water, the water in the glass is the system, right? The steel part of the glass, steel or plastic part of the glass is the boundary. Why? That is separating the rest of the surroundings from the system. So the steel part or plastic part of the glass is the boundary, and the remaining part is surroundings, right? One more example I will give you, right? If you want to study, suppose tea is there, tea in a glass is there, the tea is the system, the glass is the pingani, what you say, the plastic, that is the boundary, and the remaining part is surroundings, right? In a lake of water, I want to study the lake of the water, so that lake water is the system, right? The remaining all are surroundings. So the boundary of the lake is the boundary line, so which is separating the water from the surroundings, that is the boundary of the lake. So system, boundary, surroundings. These three terms you need to understand in thermodynamics. Why? Because in questions he will mention these terms: system, surroundings. These terms he will mention, examiner will mention the questions. That's why you need to understand what is system, surroundings and boundary. So universe means what is, but the system plus surroundings is called universe. What is universe? System plus surroundings is called universe. So what is system? Specified object or path under study, right? Specified thing under study is called system, right? So what is the surroundings? Other than the system is called surroundings. Okay, other than the system is called surroundings. What is universe? System plus surroundings. System plus surroundings is called universe. The boundary, what is the boundary which is separating the system and surrounding? The boundary is the real or imaginary. Imaginary also, you can imagine also. Real, imaginary, permeables which allows from one side to another side. Impermeable, real or imaginary, or diatomic or adiabatic. It may allow the temperature to pass from system to surrounding or surrounding to system. It may be adiabatic also. It may not pass the temperature from system to surrounding or surrounding to the system. So the properties of the boundary is real or imaginary. It may be diatomic or adiabatic, permeable or impermeable. I hope you understand now the four parts: system, specified path under study; surroundings, other than the system is the surroundings; boundary, which separates the system and surroundings; universe, systems plus surroundings. Now we are going to study the types of the system. System, I told you a specified portion of the universe under study that we discussed. Now the types of the system is, there are three types of system: open system, closed system and isolated system. Open system, closed system and isolated system. What is a open system? So I am boiling the water in a mug. No closing lid, nothing is there. I am just open vessel, I am boiling the water. That is the open system. In open system, what happens? If you boil the water, what happens? Water will get evaporate, isn't it? Water will get evaporate, and temperature also will transfer to the surroundings. So open system, water is getting into water vapor and exchanging to the surroundings. Water is converting to the water vapor and converting to the surroundings. That means there is exchange of mass, isn't it? There is exchange of mass. And temperature also. By water vapor take the temperature with it. Water vapor take the temperature with it. So there is exchange of both mass and temperature in an open system. So we can write here, in an open system there is exchange of mass. There is exchange of mass and there is exchange of energy. Energy means in the form of heat. And in open system we say dithermal wall. Open system dithermal wall means it allows the temperature to pass through it. Okay. So next, coming to the closed system. This is the system where we are boiling the water in a completely closed vessel. Assume that in a closed system we are boiling the water in a completely closed system. So what happens if you boil water vapor? There is no chance to water to escape as a water vapor. There is a no, why you are completely sealed the system, you completely closed and boiled it. So there is a no chance of water to escape it to the surroundings. So there is no exchange of mass energy in closed system. There is no exchange of mass energy in closed system, but the heat come outside. Right? So that's why. So there is exchange of heat. The energy or heat. There is exchange of heat or energy. So closed system, I am boiling. Water molecules are not escaping, but the heat is passing from system to the surroundings through the walls. So that is the closed system. Next, coming to the isolated system. This is completely closed, and assume that the walls of the container, the walls of the vessel or the walls of the container doesn't passing the heat through it. So that vessel, that container walls is completely adiabatic. That is called adiabatic, which doesn't allow the heat to pass to the outside, to pass the heat from system to the surroundings. It is completely closed. That is called isolated system. So isolated system, right? Mass also not exchanged. Why? Completely closed. So there is no chance to mass to escape. And coming to the energy, it is completely adiabatic. It does not allow the heat to pass throughout it. So energy also doesn't go out. So there is no exchange of heat in isolated system. So we can give the statement: open system, there is exchange of mass and energy both. Open system, there is exchange of mass and energy both. In a closed system, there is exchange of mass. There is exchange of energy, no exchange of mass. In isolated system, no exchange of energy, no exchange of mass. I repeat, in an open system, there is exchange of mass and energy. There is exchange of mass and energy. In a closed system, there is no exchange of mass but exchange of energy. In isolated system, there is no exchange of mass, no exchange of energy. Right? Next, these is the basics. Right? The types of system. These are the basics: open, closed, and isolated. Next, coming to the properties. These properties. Sometimes direct question will come: what is intensive property and what is extensive property, like that. So I am going to explain over here. The intensive properties are mass independent properties. Right? The intensive properties are mass independent properties. Suppose if you take density, right? Density, temperature, pressure, right? Pressure, molar heat, molar volume, right? Specific heat. So these are mass independent properties. So they don't depend on the mass. Melting point, we can also say melting point, right? Melting point, boiling point. These are mass independent properties. These are non-additive properties. So intensive properties means mass independent properties. Extensive properties means mass dependent properties. Extensive properties means mass dependent properties. Extensive properties are mass dependent properties. So what will come? Mass, volume, moles, enthalpy, right? Internal energy, right? Mass, enthalpy, complete heat, total heat capacity, total heat capacity, Gibbs free energy, right? Gibbs free energy, entropy. So these are the extensive properties. These are additive in nature. These are additive in nature. Okay. So intensive properties are mass independent properties. Extensive properties are mass dependent properties. Sir, how can you say that is mass is an extensive property, right? Volume is an extensive property. The temperature is intensive property. I will give an example, so that will give you some idea to identify which is extensive and which is intensive, right? I have a glass of water. Assume that I have two glasses. One glass I have with full of water. Another glass is empty. Another glass is empty. Now this the glass with water I have the mass of 10 grams. Assume that the glass with full of water I have the mass of 10 grams. I transferred half of the water to another glass. Then how it will become? This glass 5 grams. This glass 5 grams. This glass. Initially, I have the glass with full of water 10 grams. I have transferred to another glass. Of half of the water I have transferred to another glass. Now this glass is 5 grams. This glass is 5 grams. So mass is changing. Mass is additive. So m1 plus m2 equal to 10. Mass is additive, right? So mass is dependent. Mass. So it is called extensive property. Next, volume also same. Volume also same. Suppose in the same condition, observe carefully, in the same condition I have this water temperature is 100 degrees centigrade. This water temperature is 100 degrees centigrade. I transferred half of the water to another glass. What is this glass? What is the temperature of water in this glass? 100 only, right? It won't become 50. Got the point? I have glass with water with 100 degrees centigrade temperature. I have transferred to it another glass. Now this glass, water in this glass also 100 only. It is not additive property. We can't say 100 plus 100 200, right? So that's why. So temperature is an mass independent property. So temperature is an intensive property and mass is an extensive property. I hope now you got clear idea. Now you get the pressure. Atmospheric pressure everywhere is same. Atmospheric pressure. If there is a room. That suppose that room pressure is 1 atmosphere. There is a room pressure is 1 atmosphere. So by keeping the wall in that room, by dividing the room into 2 parts, by keeping the wall, the pressure won't change. The pressure still remains 1 atmosphere in the 2 parts of that room. That means it does not depend upon it is independent of mass. It is independent of mass. So pressure is an intensive property. In such a way, we can identify which is intensive property and which is extensive property. The property which is independent of mass is intensive property, which is dependent on mass is extensive property. Water density. If you take water density, 1 glass of water, same the density only. If you take bucket of water density is same. In a pond, lake water, the water density is same. But the water mass is different. In glass of water, mass is lesser than the bucket full of water, right? So bucket full of water mass is less than the water in the lake. That's why mass is mass dependent. Volume is mass dependent, right? So this volume is in such a way we can identify which is intensive property and extensive property. So, and one more important thing you need to observe here is just you can say, if you mention the terms molar and specific, generally that heat capacity, so here heat capacity. Generally, heat capacity is an extensive property. Heat capacity is an extensive property, that means mass dependent property. Suppose if there is more amount of substance, more heat is required to make it hot, isn't it? If it is small amount of substance, less heat is enough to make it hot, isn't it? So small amount of substance, less heat is enough to make it hot. So if it is big amount of substance, more heat is required to make it hot, right? That's why heat capacity is an mass dependent extensive property. If you mention the terms molar or specific, those become intensive properties. By mentioning the terms molar or specific, molar means 1 mole we are calculating, specific means for 1 gram we are calculating, right? For 1 mole, 1 gram, we are fixing the amount. That's why, so they become mass independent and they become intensive properties. Finally, I will give the summary. Intensive properties are mass independent properties. Extensive properties are mass dependent properties. Intensive properties are non-additive, but extensive properties are additive in nature, right? And one more thing, melting point and boiling point also. If you take 1 gram of ice, its melting point is 0 degrees centigrade. If you take big block of ice, same its melting point is 0, right? So you just what you mentioned, melting point of ice is 0, boiling point of water is 100 degrees centigrade. Whether you take glass full of water or bucket full of water, the boiling point of water is 100 degrees centigrade only, right? So these boiling point and melting point are mass independent properties. That's why they are intensive properties, right? So intensive property is mass independent, extensive property is mass dependent. So density, temperature, pressure and dielectric constant. Here the dielectric constant also will come. Molar heat capacity, specific heat capacity, melting point and boiling point are intensive properties. While coming to the extensive properties, mass, volume, moles, enthalpy, internal energy, total heat capacity, Gibbs free energy, entropy are extensive properties. I think now you got clear idea about intensive and extensive properties also, right? So system, the specified portion of study. Surroundings other than the system. Boundary, which separates the system and surroundings. Next, system, 3 types of system. Open system, exchange of mass and heat. Closed system, no exchange of mass, only exchange of heat. And isolated system, no exchange of heat and no exchange of mass. Next, intensive properties, mass independent properties, right? So these are non-additive in nature. Extensive properties, mass dependent properties, those are additive in nature, right? Next, coming to the state function and path function. We have 2 functions. In examiner in question he will give directly sometimes state function. That's why you have some idea. The state function means which is only dependent on initial value and final value. So how it is, right? So I think this is V1. Assume that this is V2. This is V2. So the change happened like this. In one way the change happened like this. In another way the change happened like this. The volume change happened like this. So in one way the change happened like this, but the starting point and ending point same for both. But the starting point and ending point same for both, right? So if you calculate delta V, it will come same for the two things. It will come same for the 2 things. Why? Because state functions only depend on initial and final stages. State functions only depends on initial and final stages, and how the changes happen, state function doesn't bother. How the changes happen, the state function doesn't bother. State function, so the changes happen from initial value and final value only. So for these 2 paths, delta value is same, right? So it doesn't depend on the path, it only depends on initial and final value. If you come to the path function, it depends on the path. It depends on the path only. The path function, if you have work is W1 to W2, it happens like this. In another way, W1, W2, it happens like this. If you have W2, so the delta W value, so if you take the W value, so in this case, straightly it happened, so less work is enough. In this case, he has to do more work, to come to this point. In first point, directly he went to W1 to W2. In this second path, he went this way from W1 to W2. That means in second time, he did more work. So work is the path function. So it bothers how the path happens, how the change happens, right? So state function does not bother how the change happens, it only depends on initial and final value, but the path function, it bothers how the work happens, right? How it comes to the from one point to another point. That's why state function depends on only initial and final values, but path function depends on how the change happens, depends on the path also, right? We have the state functions. Right, the example for the state functions are pressure, volume, temperature, right? So delta U, right? Delta H, These are the example for the state functions. That means they depend on initial and final values. While coming to the path functions, work and heat are examples of path function. W resembles work, Q resembles heat, W and Q are path functions. Right? Well, coming to the definitions, what is the heat? Coming to the definitions, what is the heat? It means the flow of energy due to temperature difference. I have two objects. One object is 100 degrees centigrade, another object is at 80 degrees centigrade. I have two objects. One object is at 100, another object is at 80. So the temperature flows from 100 to 80. The temperature flows from 100 to 80 due to the temperature difference. One is 100, one is 80. That's why from 100 to 80 the temperature is passing. So the temperature difference is the heat factor. Energy is flowing. So the definition is the energy passing due to the temperature difference, that is called heat. Work is the energy against the energy happened against the external pressure, right? The energy against the external pressure is work. The energy against the external pressure is work. The energy passed due to the temperature change is heat, right? So this heat and work I am going to explain in detail, right? Just now understand the heat is heat is passed due to change in temperature, and the work is the energy against the external pressure. The energy against the external pressure is work. Now coming to the internal energy, right? So I will give this some idea about the internal energy that will be very useful in doing the calculation. So internal energy means sum of all kind of energies, sum of kinetic energy or potential energy or bond energy, right? The sum of all kind of energy is internal energy. So some object is there, object is moving, it has kinetic energy, right? So the molecules in the object are binding together, binding energy. So like that, summation of all kinds of energy is the internal energy. Internal energy, just now I showed you, internal energy is the state function. Internal energy is the state function, and it depends on temperature. So for delta U, we can't calculate the exact internal energy. Always we can calculate the change in internal energy. Always we can calculate the change in energy. Change in internal energy. We can't calculate exact internal energy. We always calculate the change in internal energy. It is an extensive property, right? It is an extensive property. That means it is mass dependent property. Mass dependent property. Small stone is there, big stone is there. Small stone is there, big stone is there. Both fell down upon our head. Which cause more damage? The big stone will cause more damage. Why? It has high kinetic energy while falling, right? So it has high kinetic energy and it has high potential energy also, right? So that's why the internal energy depends on mass, right? That's why it is called extensive property. So internal energy, sum of all kinds of energy, kinetic, potential energy, and it is a state function, right? It's state function, so it depends on initial and final values. It's also temperature dependent, and it is an extensive property, right? To understand better, we have to understand some process that is called isobaric process, and isothermal process. Isobaric process means pressure change is zero. Isobaric process means pressure change is zero, pressure is constant. Isochoric process means volume change is zero, volume is constant. And isothermal process, temperature change is zero, so temperature is constant. So I will show you how to draw the graphs. Sometimes they will directly ask you the question. That's why I will show you how to draw the graph. Right? For isobaric process, I told you just now the pressure is constant. That's why straight line will come. Right? Sir, why straight line is coming? Pressure is constant means why straight line is coming? We may ask you a question. Right? If you observe this carefully, if pressure changes means in this way pressure will be rising. Right? Like in graph how it will be values 1, 2, 3, 4, 5. If pressure changes means, right, like this two lines will come. If pressure changes means two lines will come. So this will become P2, this will become B2, right? So we can calculate the pressure change P1 minus P2, isn't it? If pressure changes means again one line will come, we can calculate the pressure, change in pressure P1 minus P2. But here pressure is not changing, that's why a straight line is coming, right? So pressure is not changing, that's why a straight line is coming. So this is the This is the graph for isobaric process. When we have taken P on the y-axis, V on the x-axis. Now coming to the isobaric process, right? Isobaric process, we have the ideal gas law, PV equal to nRT, right? PV equal to nRT, right? V is directly proportional to temperature. So V is directly proportional to temperature. If in such a case, the graph will come like this. If V is directly proportional to temperature, the graph will come like this. If y-axis it is P, here it is T, same it is isobaric process, pressure is not going to change, that's why straight line will come. It is isobaric process, pressure is not going to change, straight line will come. In isobaric process, same here TC, here it is V, so straight line will come here. So it is V, straight line will come here. In isobaric process, right, here V against T, so in V, straight line will come like this. Here check here, V at the y-axis and T at the x-axis, but there is no change in volume, so straight line will come at T. Now here again ideal gas equation will be applicable. PV equal to nRT, P directly proportional to T, so straight line will come like this. Straight line will come like this. So isobaric process means volume change is 0. Next isothermal process, temperature change is 0. Isothermal process, temperature change is 0, right? So here PV means PV isothermal process, PV equal to nRT, right? Here ideal gas law will come. PV equal to nRT, we can say PV equal to constant. PV equal to constant. So PV equal to constant means the graph will come like this. If PV equal to constant means the graph will come like this. Here again v-axis and T is there in x-axis. T is there in x-axis. So the line will come like this. Why? Because change in temperature is 0. Again here T is in x-axis. So the graph will come like this. The change in temperature is equal to 0. So we must understand isobaric process, pressure change is 0. So find where P it is, right? So they give a straight line. If isobaric process P is not there, if isobaric process P is there, straight line will come. If P is not there, then go for ideal gas equation. Ideal gas equation. So in ideal gas equation, find the relation between the two. If proportional will come, then straight line will come here, right? So then line will come here like this. Next, isobaric process, wherever V is there straight line will come, right? Wherever V is there, straight line will come. If V is not there, go to the ideal gas equation. If proportionality is there, then graph will come like this. Line will come like this. Okay. Next, isothermal process means wherever temperature is there straight line will come. If temperature is not there, right? So other than temperature, PV terms are there. Then go for ideal gas equation. Then if you analyze the equation, PV equal to constant will come. If PV equal to constant means the graph will come like this. Okay, I will give summary. What we have learned in this class is system, the specified portion under study. Boundary, it separates the system and the surroundings. Surroundings, other than the system, the remaining are surroundings. We have three types of system: open system, closed system and isolated system. Open system, exchange of heat and mass. In a closed system, no exchange of mass, only exchange of heat. In isolated system, no exchange of heat and no exchange of mass. Next, we have two properties: intensive properties and extensive properties. Intensive properties are mass independent properties, extensive properties are mass dependent properties. If you find the terms like molar, specific heat, terms are there, then you can judge it as intensive property, right? Intensive properties are non-additive in nature, extensive properties are additive in nature. Next, state function, which depends on initial and final states only, right? So you have the example: pressure, volume, temperature, and change in enthalpy and change in internal energy. Path function, which depends on the path how the change happens. We have two functions: work and heat. Next, heat is Q. Work, we have heat is so the energy flows due to the temperature difference. The energy transfers to the temperature difference. Work is so the external the pressure, right? Work is the energy against the external pressure. We have PV work and non-PV work. PV work and non-PV work. And PV work we have two types: expansion work and compression work. That I am going to explain in detail. Okay. Now, internal energy, sum of all kinds of energy, right? Kinetic energy, potential energy, and bond energy. It is a state function. It depends on temperature. It's state function. That's why we are writing U1 minus U2. So it is an extensive property. That means it depends. A big substance has high internal energy rather than small substance. While a big substance has high potential energy, small substance has low potential energy. That potential energy also is part of the internal energy, right? So next come to the isobaric process. So how these process I will explain. Now understood. For isobaric process, pressure is constant. Where P is there, that straight line will come. If other than P is there, then derive the developed by ideal gas equation and then the other graph. Isobaric process where the volume change is 0. Isothermal process where the temperature change is 0. So to remember the intensive properties, today trick is, right? So BP of Mr. VC decreases totally. So to remember the intensive properties, today's trick is that, right? So here B stands for boiling point, P stands for pressure, B boiling point, P pressure, right? So here M stands for melting point, V stands for viscosity or vapor pressure, V stands for viscosity or vapor pressure, C concentration, D density or dielectric constant, right? Density or dielectric constants, T stands for temperature. T stands for temperature. So by this trick, you can remember some of the intensive properties. I repeat: B stands for boiling point, P pressure, right? M melting point, V viscosity or vapor pressure, right? So C concentration, D density or dielectric constant, E for electrode potential, right? T is temperature and surface tension, right? So by this code we can remember some of the intensive properties. Thank you.